Hi out there. I am Henrik Solver, Director, Head of Sales and Business Development in Itera. Welcome to everybody out there to this very interesting webinar. You come from a lot of different countries, to mention a few: Denmark, Norway, Iceland, and even Brazil and Italy. We truly have an international agenda and audience. Thank you for that, everybody. We from Itera and Cognite hope that you are excited to learn more about trends within the power and utility sector, and we will tell and show you how we make a difference in the market of digitization and transformation of the power and utility sector. It's a digital journey where we, based on a lot of data sources and processes typically disconnected today, bring in high quality solutions and empowerment of your data and workforce to gain the max value, including a lot of new insights. I'll now hand over to Sarah from Cognite. Sarah, the word is yours.
Thank you, Henrik. My name is Sara Lexo. I am Director of Sales and Business Development in Cognite. For this webinar session, we are happy to announce the following presenters: CEO of Itera, Arne Mjøs, and Gabe Prado, Director of Marketing for Power and Utilities in Cognite. And some key takeaways from this webinar includes technology trends for the industry and how we enable companies to do more with data. Please feel free to post questions during the session. You will find a chat function in your upper right corner. We will arrange for a question and answer session at the end of the webinar, as well as one-to-one follow-ups if preferred. And with that, I would like to welcome you, Arne, on the stage.
Thank you, Sarah. Hi, everyone. I think I will start with a brief introduction of Itera. So if you could go to the next slide, please. Itera is a specialist in creating sustainable digital business with a strong footprint in the Nordics. And we also have a very strong partnership with Cognite. We are close to 600 people and deliver services to about 20 countries around the world. What we do is actually to deliver end-to-end services in industrial transformation through our multidiscipline teams, where we always combine user experience or customer experience with business domain knowledge and technologies. So we always start with the user, and by combining these kind of competencies, we always try to create sustainable digital business. We have a strategy, we call it platform first. That means that we apply a platform thinking approach to drive innovation, both in terms of data-driven business platforms and also technology platforms. We strongly believe in the fusion of software and energy and have a mix of customer and partners, both within oil and gas industry with its green transition, including floating wind, power utility industry, and not at least also software industry such as Cognite, Microsoft, Amazon, eSmart or Kafka, whatever. Please go to the next slide. If I'm looking at the main drivers for change and disruption in power and utility, I refer to Microsoft Smart Energy team in Redmond. So as you see, the future for energy is actually disrupting everything. If you look at some of the figures, by 2020, overall electric use is expected to grow more than 50%. And by 2035, more than 50% of electricity will be generated by renewable energy. If I look to Nordic power system, it's a mixture of generation sources where hydro, nuclear and wind power are the main sources. The power system in the Nordic is actually currently undergoing substantial changes towards more small scale and distributed power. And if you look to Norway, the share of renewable is close to 100%, in Sweden 69%, Denmark 29%, and in Finland 53%. So if I'm looking at the drivers for change and disruption for power and utility globally, is very applicable also for Nordic, and I think it's even stronger in the Nordics than the rest of the world. So what we see is actually there is a developing on new grid operating models. There is increase in electrification of the industry and consumers, and also not at least including more and more renewable and distributed energy resources such as wind and solar. In the Nordic region, there are many energy-intensive industry and a large share of electricity heated houses. So our energy company in the Nordic are helping customers to cut carbon emission, not just by greening their energy supply, but by electrifying additional end users and powering them with clean energy. There is also a spotlight on the transportation sector as electric vehicles become increasingly attractive for car buyers in all the Nordic countries, but not at least also fleet operating, and we see more and more ships and more going into the electric space. If you look at the energy consumer, it's getting smarter, characterized by everything being digitized in our societies, like homes, cities, whatever. And the consumer are also becoming a producer of energy. And as you all know, COVID-19 is accelerating digital innovation in almost every industry, and not at least also in power utility. And because of that, we also see that many industries and companies are setting quite ambitious sustainability goals driven by the climate policy and technology development. Next slide, please. So if I look into the energy landscape, is actually becoming more complex and integrated. Energy companies are facing increasing economic and environment pressure to cut costs, reduce CO2 emissions, and limit occupation of land. While the old world utilities of today still generate and distribute electricity the same way they have done for the past 100 years, whatever, successful new entrants deliver customers renewable, distributed, and low marginal cost electricity like solar and wind that can be even generated at home or at their business. Any excess production can be stored in battery or sold back to the grid, all controlled through advanced software. So in this integrated market, flexibility is a very key issue for many players. The value of being able to offer flexibility is great and an important area for many players. And there are energy companies of the future that must find this kind of solution. Some utilities are exploring transactive energy models to enable customers to create value through rooftop solar, storage, managed EV charging, whatever, and even eventually also vehicle to grid transactions. Many see such markets as key to the industry future, as they can incentivize customer participation and boost grid flexibility. So in order to succeed in this market, so we go to the next slide, there is a lot of technology out there in the market. So an advanced software that will unlock the new capabilities for power and utilities. Here are just some examples, for instance, using augmented analytics for demand forecasting and asset failure, or using artificial intelligence with more situation-based data for production planning, or even blockchain for smart contracts for auditability and compliance, but also a solution with potential to help manage the new grid that includes a lot of distributed energy resources. At Itera, we are very eager to transform the power utilities through the fusion of software and energy. And there are a lot of projects to digital power utility really going on. For instance, many energy companies have started data lake project for augmented analytics, while others are investing a lot into some kind of digital twins. Very often these projects are getting very large and complex, where the real challenge is actually to convert data into actionable knowledge. Next slide, please. So the key question is actually, how do we unlock the power of data or industrial data in power and utility, enabling companies to deliver value at speed? And that is why Cognite Data Fusion is really about, that we will talk about later. Just to show you an example of this is actually how we deliver a project for Kværner during this summer holiday. Kværner Yard build advanced offshore-onshore platform or renewable energy solutions or floating production units with thousands of assets such as wagons, production equipment and trucks, lifts and more that always are in continuous motion. So what we did was actually to put together a multidisciplinary team of 7 students with skills within business consulting, user experience, data science, and tech people, coached by some senior people from Itera to develop a new visual asset tracking solution that facilitates asset tracking, fleet management, and navigation at the yard for Kværner. So the project during just 7 weeks, and then I'm talking about the first 2 weeks was actually to onboard these students. They didn't know anything about the yard at all. But after a while, they managed to build a new solution, this visual asset tracking solution, which has make tracking information available for all the employees through this app, and give present a map that give the user an overview of the yard and up-to-date information of all the assets. In addition, we used a robotic to make sure that we also managed to develop a 360-degree street view as a part of the app. By using different technology for asset tracking, such as GPS, RFID, image processing, but not at least robotics, we managed to keep track of all kind of movable assets and make very physical object on the site searchable through the app. We were using Cognite Data Fusion to contextualize different fragmented sources of information and enable the team to focus on the user and deliver value on selected use cases at speed and scale. And indeed, due to the COVID-19, the team didn't even manage to meet the client. So we need to work from Oslo, sitting remotely, and design and build together with the people working on the yard. So I think this is just a good example of a project at speed, delivered by a multidisciplinary team of competencies and even students, by digitizing and contextualizing the value chain at the yard and convert data into actionable knowledge. So the business case was really exploring and extended during the project because we were showing real value for the end user or for the business stakeholders. So that is some kind of introduction into what we mean by speed and also at scale. So let me hand over the mic to Gabe from Cognite to tell more about
Great, thank you, Arne. I think that was a great example and introduction into why the data environment is so important and what some of the value can be unlocked with the right combination of partners and the right combination of software tools. So a little bit about Cognite before I get into some of the more nuanced aspects of data fusion and contextualization. But Cognite is a market-leading software company that powers industrial digitalization. So we're actually born out of industry to solve problems with very specific industrial data sets where there were no software solutions at that time. So a lot of this involves being able to more fluidly facilitate the exchange of data from its source all the way through to the application. The last 2 years of my career were actually spent at an AI machine learning startup. And one of the reasons why I left to come join Cognite was because the reality is that very few industrial organizations have really invested in the data management to apply AI at a broad scale. So there's some foundational data challenges that a broader group of customers can overcome, which Cognite is really focused on and which I'll go into in a little bit more detail. So our commercial offering is based around two products: Cognite Data Fusion, which is our data platform, and then also a suite of Cognite applications, which are use case specific to the particular business problem. And as you can see, we serve customers across major heavy asset industry, including oil and gas, power and utilities, OEMs, and shipping. And it turns out that a lot of these same problems that exist in oil and gas, for instance, can apply to power and utilities or apply to shipping. So we're really about taking the learnings from these individual projects and applying them to future software that can be deployed at scale and actually enable the ROI that the industry has been expecting. Now, at the end of this journey is the value that the industry has been talking about for decades, right? There's a tremendous amount of ROI at the end of digital transformation. And what we're starting to see from our customers are these various buckets of value that actually exist in changing the way they work and changing the way that they use their data. So data-driven maintenance, for instance, is a really key application area because it has both top line and bottom line impact. If you can get more predictive in your maintenance operations, you can increase the uptime of your assets, increase the productivity of them, and then also streamline how you perform maintenance on those assets and lower costs at the same time. Additionally, with aging assets and with changes to our infrastructure, it becomes really important to keep an eye on asset optimization. Can we get the production from the asset on different conditions based on different requirements and increase the amount of productivity as a result, as well as maintaining both quality and yield metrics. Another trend that Arna mentioned is the need to work more digital. And we're seeing a lot of activity in the market around digital workers where they're empowered with data in the palm of their hand. They're empowered to make decisions and they're empowered to collaborate better with their teams to actually execute better on their maintenance tasks. And already in production, we've seen a massive amount of increased worker productivity as well as the amount of time it takes to perform specific maintenance actions. All of this drives towards a more safe, more sustainable workforce as well, or workplace as well, right? When we can get more predictive instead of being reactive, the landscape becomes safer and we can increase the sustainability of those operations and start to uncover additional business models that are only unlocked by better application of data. My opinion is that if you can harness the power of your data to get really good at unlocking the patterns that are developing around you, you can harness that for competitive advantage and a rapid approach to adjusting your business model to adapt to the specific market. Now, this is great and everything, but the reality is that getting there is complicated due to the inherent complexity that exists in the industrial space. So if you look at a couple different operating environments, you see oil and gas drilling, you see FPSOs, you see a hydropower plant. The reality of the situation is that there are a lot of different vendors, a lot of different data silos, because data has traditionally been engineered and created for a very specific use case. There's a turning point now in the industry where that data is needing to be applied at a broader scale and must be tapped from those silos to be used across the organization rather than just for a very specific, perhaps time-bound use case. And a good way of illustrating this is really just in kind of picking apart the different data challenges that we see every single day from our customers. On one hand, there's this creation of additional data silos. This could be created by a new system that has to be deployed or a new vendor that gets added to the mix of digital vendors. But the reality is that data is becoming more siloed across the organization, and this leads to inefficient data access and availability. Now, with this same access and availability, there are challenges with data trust, right? If you have multiple copies of your data across the organization, which one is the single source of truth, right? And this can lead to poor decisions if you are implementing bad quality data in a particular machine learning pipeline or into a particular application. There's a clear need for visibility and integrity across the entire data to application value chain. So you need the trust from your users and you need the data quality checks that actually make the data valuable in a production environment. Additionally, if you haven't solved the first two problems with automation and with additional checks, you start to have to add more humans to the mix. And this starts to impact the ROI that you expected from digital, right? A really good example here is data scientists who still spend 80% of their time just looking for data. Now, those are very highly skilled employees that should be focused on the highest priority projects rather than spending all their time still looking and trying to manage this data that exists in all these different silos. What this does is then it extends the timeline for model development, making projects maybe take 6 months or more to actually deploy. And if it takes you a long time to build your model and then deploy your model, that model may not even be relevant anymore at the time that it gets deployed based on seasonality, based on changing asset behavior. And so there's a really, there is a real need to be timely in the way that we process and use data in production. And then lastly, I think one thing to think about here is that if you're not addressing these problems, they start to snowball. And at some point, you create a tremendous amount of complexity across your organization that actually further slows down your means to use and apply that data for business value. Now, a great example here is just the process for creating a dashboard. This is taken from one of our customers, and you can see across the left just how many people are involved in actually creating a little bit of operational visibility based on a set of data sets, right? There's a lot of back and forth, there's a lot of separate processes, there's a lot of handshakes and handoffs, and the reality is that this is relatively complicated for a rather straightforward approach to creating a dashboard. If you start to think about more advanced applications like robotics and machine learning, you can see how this quickly becomes even more complicated than just creating a dashboard. So it's a very real problem. The other thing to think of mind is that we have to be able to walk before we can run. And I like to break digital success down into several categories of maturity so that there's somewhat of a roadmap for how data can be applied to the end goal of these really advanced applications. So one main category of maturity is really just around data operationalization. If you know that you have a lot of data, but you haven't quite been able to visualize it or haven't quite been able to mobilize it for the right users, the challenge is really around extracting the data from the control systems, from the silos, into a manner that can then be operationalized through dashboards, through monitoring, digitization of diagrams. And this really enables faster decision making, such as optimizing turbine startups, which is a use case which I'll talk about later on in my presentation. The next category of maturity is really around optimizing workflows. So once you're able to make more decisions based on your data, the next step comes into fine-tuning the workflows that go into supporting a particular task or process at your organization. So production and maintenance activity planning, better anomaly detection and management, these are workflows that can be impacted once you become more predictive. And the business value here is really around improving quality and efficiency, improving the exchange of information, and generally reducing the task time by 50 to 80%, as well as moving from a reactive approach to a more predictive approach. The last category here is really around smart automation. So once you've been able to really focus in on your workflows, then you can start expanding into robotics, more advanced applications around inventory management, and streamlining a whole process end to end with better automation. So this unlocks opportunities to perform better inspections with robotics and really maximize the HSE at your operations, while at the same time further reducing your O&M expenses through automation. Now, what's interesting about this is that these various stages of maturity depend on an increasingly complex technology stack. So on the lower end, the problems are really around data extraction, pipelining, access, contextualization and delivery. And then as you move up the chain, it becomes more around advanced analytics, AI, machine learning, hybrid modeling, and then additional logistical models. So what's interesting here is that you need the infrastructure and the data ecosystem that's going to enable you to grow in your applications rather than keeping you at one level and then having to invest more in a different level. So we're really confident that our Cognite Data Fusion platform actually enables the succession of these various stages of maturity so that customers can continue to progress in their digital transformation. Now, it really comes down to how you deploy digital. I talked about the world of data silos. We also have more data consumers than ever in the mix. We have data scientists, we have data engineers, we have subject matter experts, we have business analysts, all trying to better use data to make better decisions. And then at the same time, it's still complex to operationalize. So all of this together is really demanding a change in the way that we think about data management practices and how we apply it to our applications. And this really brings us to best practice one, around bridging this gap between data, humans, and process through data ops. Now, Gartner defines this as a collaborative data management practice, which basically improves the communication and automation of data flows between data managers and consumers across the organization. So this is really a practice around data mobility so that the data can be made available and useful to the people at the right time, at the right place for the right application. And like I mentioned before, this practice solves a lot of the challenges that we're seeing from operational technology, right? There's a strong OT and IT data divide still today, where there's miscommunication and not necessarily, there's challenges in bridging the OT and IT gap. Additionally, making sure that data is high enough quality and readily available for advanced data science. It improves data quality. It also sets up the foundations for scale and starts to accelerate the rate of innovation within the organization, right? So if you're able to better use your data more quickly, this improves the timeliness and the rate of innovation and starts to increase the success of digital projects in production. Now, Cognite Data Fusion is Cognite's data ops offering. And at a very high level, this is what the platform accomplishes. First, it spans the unlocking and the unleashing from data silos across OT, IT, and visual data sources. So if you think about time series, you think about control system data, you think about events, these all exist in that OT bucket. But it's also not necessarily clear how they relate to IT data, which lives in additional systems, right? So this could be equipment hierarchy, other tabular data, work order data. These exist in different systems and haven't historically talked to the OT data in an efficient manner. And then you start to think about new data sources where the industry is looking at photogrammetry for, inspection across the grid, 3D visualizations of their power plants, more extraction of information from documents and P&IDs. And the first step of data ops is really to fuse the data and access the data from all these different systems into one location. The next step is around contextualization, which I'll go a little bit deeper on in a few slides, and then providing the data catalogs and the mechanics for advanced analytics on top of that, and then making the data distributable through APIs, through SDKs, to the different operators at that organization, whether it's a data scientist who's working on a predictive model, or all the way down to the operator who at the end of the day needs a functional application to better do their job. Now, best practice number 2 is really around solving the knowledge distribution problem. Now, we talked about data ops as a key manner for providing the tooling for data management, but at the same time, there's key knowledge barriers that reduce the impact of applications in deployment. So what you see on this screen is a rather straightforward process or workflow going into an advanced analytics process, right? There you have to get the data scientist investigates it and prepares it, make sure the quality checks are there, verifies it, and then actually creates the model and puts the model in an asset framework. Now, there are some physical barriers here, right? The data scientist still needs to be able to pull the data from where it exists, but there's a broader set of challenges around knowledge, right? And what this means is that does that subject matter expert, does that data scientist even know that the data exists to solve their particular problem? Do they know what additional data might exist that could augment that initial data set? Do they know where to find the data? And really just challenges with data awareness. Additionally, like I mentioned earlier, there's a quality aspect to this as well. You have to be able to guarantee data quality throughout this entire pipeline, and also contextualize it and understand what the data means without having to be a specific domain expert or subject matter expert in that particular data set. Right? A data scientist, for instance, is very good at creating models and finding the right algorithm for the problem, but may not be an expert in the tagging or the asset hierarchy or the structure of the data that was created for them. And then lastly, they need the means to collaborate with the team to make sure that the knowledge is shared and that they're able to accelerate this end-to-end workflow. The solution here is really, the contextualized operating data model or digital twin or data ops platform, and then also the upskilling of the people involved in data at that organization, whether it be the citizen data scientists, subject matter experts, or engineers. Part of this can be fixed with tooling, and part of it can be fixed with training. Now, this brings us to the point about automatic data contextualization. And this is an area that is really strong in Cognite Data Fusion. And this is really addressing the knowledge barriers where through automatic data contextualization, we add human-like meaning to all this different various unconnected data and create a knowledge map that identifies and demonstrates the relationships. So I mentioned that there's a lot of different data across the organization, but inherent to CDF is a IT and OT data contextualization engine, which actually extracts different resource types from that data, pulls information from documents, and turns all those different data objects into templates that can then be used to create a knowledge map. So the knowledge map on the right is a good representation of a transformer, right? So if you think about your grid network, you have transformers across that network. This knowledge map helps you identify which substation those transformers are tied to, which OEM that transformer, what make and model that transformer is, whether to step up, step down. All the different attributes can then be mapped to the transformer, and they can then be mapped to various aspects of that entire grid model. So humans can do this when they really understand the data, but it is a high overhead task that when you're dealing with millions and actually billions of data points, automatic contextualization becomes a key part of mapping the relationships so that the end user doesn't necessarily have to focus on the data and can actually focus more on the problem because they understand the meaning behind that data set. Now, what this unlocks, so if you think about data ops and contextualization is addressing the tooling and the knowledge gaps, this is effectively what unlocks scale. So when we're today thinking about single asset models, the opportunity comes in improving the data quality and lowering the costs of actually deploying that model at scale. That's what data ops helps with, right? Moving from a single wind turbine to hundreds in the field. Think about it for a combined cycle power plant. You've got a really complex model for a combustion turbine, but the reality of your plant is that there is diversity in that there's the HRSG, there's a compressor, there's other assets that need to be modeled at a system level to actually understand the health of that particular plant. And I mentioned some use cases across the grid as well, right? I think power and utilities has a tremendous opportunity to, or is a function of scale through distributed systems, through distributed networks, and using data to address that scale is possible with data ops and contextualization. Now, some of the examples that we have from our experience are around various use cases across the power and utilities industry. And this is what I think is really interesting about CDF as a platform, right? It doesn't matter necessarily what data you have or the use case you're trying to solve. Cognite Data Fusion facilitates that exchange and the creation of applications so that you can use the data that you've got for very specific use cases. So in the case of Hopsel-Neco, we've enabled them to optimize their hydro turbine startups and avoid unexpected downtime. Additionally, we're working with the state of California to improve real-time condition monitoring and reporting on offshore wind farm. We're working with a major TSO to better understand and predict transformer failures, as well as working with a solar farm to get better operational visibility of their operations. So again, we know that there's a tremendous amount of use cases. There's a tremendous amount of data that's in power and utilities. Our job and our intent is to help our customers really put that data to work for them. And a really good example here, if I go a little bit deeper into the Hopsel-Neco case, it kind of shows how data can be applied in a progressive sequence. So Hopsel-Neco was they wanted to be more responsive to grid demand, but sometimes during startups, they had faults during the turbine startup mode in their hydropower plant. So this kept them from being able to supply power on demand, and it was a problem that they were really focused on fixing. They had data, but it was embedded in their control systems and it was hard to use. So they worked with Cognite Data Fusion to actually extract the data from that control system and start to thinking about it in terms of dashboards. And we helped characterize those startup modes for their turbines so they could better understand and characterize what a faulty startup looked like and look for indicators for when those startups were going to be faulty and then perform maintenance as a result. So in just a matter of a couple of weeks, we're able to help them operationalize their data and start getting better visibility into their operations. Now, the next phase of that project really then involved overlaying their data onto a 3D visualization of their power plant. So we scanned the entire hydropower plant with photogrammetry and actually built a representative model of their operations and then overlaid data as a result. So what this is enabling them to do is have better warning of their startup faults, being able to better diagnose and repair their assets at lower costs, and then also increase the operational visibility of their data. Now, the last semi-best practice here is really some information from Bain & Company. What we're seeing here is that as the digital application stack and digital solution stack continues to grow, it's very important to keep a set of domain expert partners in mind as well. And this is where we're really excited about our work with Itera, right? Because we can bring the technical know-how from the data perspective, but we still depend on partners like Itera to provide domain expertise and the governance of the project to bring the data all the way into an application. So I'm going to hand it back over to Arne to talk a little bit more about the engagement model and why these partnerships are so important.
Thank you, Gabe. Yes, we have at Itera, we've done a lot of projects. Also, the same complexity that you described in your presentation, Gabe. But I think after working with Cognite, we have done, I think we have established a very good process to make it quite easy for the customer to start on this journey. So we have defined that the process into 3 phases. The first phase is actually discover, define, and deliver first value. So that's a phase period of 4 to 8 weeks, where we agree on the success criteria for the project. It should be very business driven, so we need to make sure that we have selected 2-3 use cases that the business side is actually requesting. In addition, we bring in the tools and technology by Cognite, prepare the data foundation, and start to deliver the first use case during these first 4 to 8 weeks. So that's very important for Cognite in Itera to really step up and show the value to the business side during the first phase. Then during the first phase, we also capture lessons learned and plan for the next phase, which is actually the adoption. That is about almost 2 months, where we continue with the MVPs, test them and experience and learn, and also start the adoption of the technology for the customer itself. So there's a lot of tools or Cognite Academy that is used to train the people to make sure that they will also manage to do this kind of project by themselves. And after these 2 months, we work with one asset, but then we will, based on the learnings after this 3 months project period, we start on scaling to go to the next asset, 2, 3, 4, 5, and also to new use cases. So what is important is actually that we really are committed to deliver at speed with high quality, and also be able to scale to make sure that this is not the traditional project with a long tail of a lot of lack of data or low quality. So we really focus on providing the value for the end user very early in the process. So this is a typical journey, which is very different for all the kind of project that Itera has done for our customer. The complexity is high, but I think Cognite, with this kind of unique technology, some players are saying that Cognite is actually 2 years ahead of competition, because they really industrialize these kind of challenges that we see in almost every kind of digitalization project into some kind of good processes and technology that they invest a lot into in order to be the best player in the world, in order to tackle these challenges that Gabe talked about with the typical complex digitalization projects.
Great. Well, thank you, Arne. I think we've got that's the end of our content, but I'll pass it back over. We'll pass it back over to Sarah and Henrik to help facilitate question and answers. Hi, Sarah. You might also be on mute.
Yes, I think Henrik, this is the time for you to shine again. Are you there?
Yes, can hear you now. Did we have some questions from the audience?
Yes, let's do the questions then. Okay. I think this one is directed for you, Gabe. Someone is asking, we have AI or ML solutions already. What is the benefit of your approach for these applications?
Sure, great question. A lot of it has to do, so AI, I come from the AI machine learning space, and one of the biggest challenges was in repeatability and actually deploying of AI machine learning models. Creating a model in and of itself is very involved, but it's one set of problems. The other set of problems is really in deploying and operationalizing that model for the particular problem once you reach production. So there's a tremendous amount of work that goes into, verifying the data quality, verifying the modeling approach and the algorithm used to solve the particular business problem. But then you have to containerize and then start focusing on problems such as model management, model deployment, model stability, model model retraining, and model governance, which is a whole different set of problems. So Cognite Data Fusion actually helps facilitate both of those issues by enabling data scientists to have better quality to start with and actually create the model, and then move to a deployment phase where they can package the model for the asset framework that they're trying to use. So it helps not only just the creation of the model, but also in enabling scale, because the entire timeline and the entire life cycle of creating that model through deployment becomes very reduced.
Okay, thank you, Gabe, for that thorough explanation. I think, Arne, are you ready to cover the next question here? This is a question stating, we are running a data lake project. Is Cognite Data Fusion an alternative solution for this?
Yes, that's also a very good question, because that is some of the first question we get from all the customers that would like to go into looking for Cognite. And I won't say that Cognite is not any kind of conflict with the data lake solution. Cognite Data Fusion really extracts operational data directly from different source systems. That could also include data lakes or data warehouses. And Cognite Data Fusion can also supply the data back to the data lake. So if you have already started with the data lake, it's not any conflict at all. I think Cognite Data Fusion is really industrializing the way to contextualize your data, to create relationship with meanings across old data, new data, whatever. And that is some kind of gap I feel in a lot of projects out there. There's some customers that are working with Siemens, whatever, so have a lot of different systems. So I think Cognite Data Fusion really fits into this kind of architecture that can extract data from all kind of sources of information and contextualize this data in a structured way. And the outcome from this process can be put into a data lake, or you reused through APIs, whatever. So for me, it's not any kind of conflict at all. It's really advanced technology that help customer to digitize and contextualize their data in a much faster way than what we have seen in the past.
That was an excellent response, Arne. Thank you for that. And what we often hear in the market is that we have started with some data-related project, but seem to struggle with the data quality. Is this something Itera and Cognite can help us with? Can maybe you start on that, Gabe, and you will continue, Arne, with a final remark?
Sure. No, thanks, Sarah. So data quality is top of mind, right? You can't have a good model or a good dashboard if your data is poor, leads to poor decisions being made. Part of this is in understanding the data and understanding the context behind that data. That's one way of understanding the initial data quality. But then as you start to operationalize it, the challenge becomes around automating some of the data quality checks as you move to operations. So some of the functions that we built into Cognite Data Fusion include a data quality monitor, where you can actually have build a collection of rules and analytics around your data, so that you can look for outliers. You can start to understand when sensors are failing. You can build some parameters to understand when your data is changing and is starting to become poor quality. That way you can trigger an assessment of, okay, well, is this a hardware problem and my sensors are going bad, or did something else break down in the data chain? So it's a combination of having the domain expertise to know when the data is of poor quality, but then also being able to translate that into rules and systems that improve the data quality throughout the end-to-end pipeline. And this is something that we built into Cognite Data Fusion.
Any final remarks from you, Arne?
Yes, I can also support the game on that. I think what is important is actually that with Cognite Data Fusion, you see the quality of the data, or you see the lack of quality. But that is the way the Cognite Data Fusion contextualization pipeline. There are a lot of tools to really connect, to create a relationship manually in order, or it's done by artificial intelligence as part of the solution. And of course, there will always be some kind of change management when you see that this area in the quality is bad, whatever, and is missing some information here and there. And that is also trigger some kind of changes in some kind of core system or whatever. But then you have a more systematic way to improve the quality. So that's this kind of agile way of working. You look at the data with the stakeholder, or from the business side with very deep domain knowledge. They see what is missing, and then you make sure that this kind of improvement of the quality is really addressed and mitigated. So when the different user or application are accessing this kind of data, you know that the quality of the data is actually approved by these stakeholders at the customer side. So I feel that the tool by itself is really increasing the quality of data in the organization, because you have this kind of holistic view of all the data, and the artificial intelligence part of the products is really, identifying relationship that you didn't know, or you didn't know about in the past, that you have this kind of additional data that could actually solve the problem with the data that you have when you always were looking at some part of the sources, maybe driven by a legacy way of thinking.
Thank you very much. And then, on behalf of the Itera and Cognite team, I would like to thank you all for your interest and participation in this webinar. Please feel free to reach out to Henrik and myself for any advice on how to get started or continue on succeeding with your digital journey. Thank you, everyone, and goodbye.